Good evening, everybody. So in the last lecture, we have to be seen the something related to the 78xx and 79xx. Okay. There should be, we know that 78xx indicate that positive voltage regulator, 79xx indicate that negative regulator. How the spin structure of that and how we have to be used for it for the different application that we have to be studied with respect to positive voltage regulator as well as negative voltage regulator. Okay. And which type of their configuration means it indicate that which type of IC or what is the count of that IC that we have to seen here. Okay. Now after all, we have to be seen the things such as different specification with respect to the half wave rectifier, with respect to the voltage regulator 78xx and 79xx. After all, we have to be seen now. One of the important thing with respect to us, that is design of unregulated power supply. This part is not asked for your MCQ type of the exam question that should be currently happen in a your exam, right? So, but for the problematic situation in a future, like you have to need of the designing of the unregulated power supply. So that's how we have to be design the unregulated power supply that we have to be seen here. Okay. See, when we have to be designing the power supply, first part is your rectifier. Okay. Rectification is needed for the generation of the unregulated power supply. After rectification, we have to be done the another thing, that is filtration. So filtration removes the unwanted component. Okay, these are the some of the types of the filter which should be used across here. This is the half wave rectifier. Okay, this is the half wave rectifier. Means we have to be seen here. We doesn't see here type of filter. We have to be seen the which of the rectifier which we have to be seen here. Okay, this is the half wave rectifier. This is full wave rectifier. This rectifier is called as full wave center type of the rectifier. See, in the configuration of the power supply designing steps, there should be one of the block diagram which should be used for the generation of the unregulated power supply. First is rectifier, then after all filter, then regulated, and then your power supply. Okay, these are the thing, but in this case we doesn't see the regulated things. Okay, up to the power supply thing means we have to be seen the block diagram with respect to rectifier, filter, and the if we needed, we have to use the regulators such as 700xx or 700xx, and we got the output. These are the two types of the rectifier. Now we have to be see the actually problematic situation with respect to this. That is a we have to be design the one of the power supply. There is unregulated power supply for different configuration. We have seen up to this. This is half wave rectifier. This is full wave center type rectifier. Means these are rectifier used for the generation of the unregulated power supply. Okay. Third is your centered bridge type of the configuration. Okay. These three type of the rectifier used for the unregulated power supply. These are the designs thing we should be used according to particular type of the filter user. See, if we have to use the capacitor type of filter, all the things indicate that ripple factor of that capacitor type of filter and the VDC for calculation of that filter that should be used. Means this row should be used for the capacitor type of filter. For the inductive type of the filter, we have to be use this R is equal to this row. For LC also we have to use this row, and pi also use this row. Okay, but one of the important thing for all of the calculation, if we have to be calculate the IDC, in that case formula is I equal to V upon R. That is nothing but IDC equal to VDC by RL. That is common for all of the either it is a CL, LC or pi type of filter. Okay, now write down what is the procedure. Write down the procedure initially. How we have to be design the particular power supply for any of the application. Procedure for designing power supply, that is unregulated power supply. Procedure for designing unregulated power supply. It is also called a step for designing unregulated power supply. First step is selection of filter. Selection of filter. First step is selection of filter. Selection of filter after all, selection of transformer. For that purposes, we have to be used one of the formula, that is phi Rm is equal to twice Vm by root 2 plus 0.7. Selection of transformer. Below that formula, phi Rm is equal to twice Vm by root 2 plus 0.7. Third is circuit diagram. These three steps followed up are the designing of the power supply problem. Okay, this should be asked in a your offline exam for 8 mark, 8 or 6 mark. Okay. Write down the problem. Design a unregulated power supply. Design a unregulated power supply using capacitor filter. See, in this thing we have to follow all of the thing of the capacitor type of the filter. Okay. Design a unregulated power supply using capacitor filter, comma, supply to give DC output voltage of 50 volt at 1 kilo ohm load with ripple factor not exceeding 3%. Okay, full stop. Use two diode rectifier circuit. We have to be read again this problem. Design and regulate a power supply using capacitor type of filter. So one of the important condition with respect to this is that we have to follow the all of the things which should be related to the capacitor type of filter only. Means for the calculation of your ripple, for the calculation of voltage, we have to follow the row of the capacitor type of the filter. Okay. Now to give the DC output means this is designed for 50 volt unregulated power supply at 1 kilowatt. This is nothing but a load, right? With ripple factor not exceed. So ripple factor value 3 divided by 100. Whatever the value coming, that is the ripple factor value. Okay. Two diode rectifier circuit, it indicates that you must have to use the central type of the configuration. Okay. Note down given data. Okay. Given data, start up with it. Design an unregulated power supply using capacitor type of filter, right? So write down here if they have not written, write down, we have to capacitor type of filter, right? Capacitor type of filter, two lines or below that, two lines, capacitor type of filter, two lines on that. Okay, below it. Now DC output voltage of 50 volt, it indicates that phi DC equal to 50 volt. Write down first point, phi DC equal to 50 volt. They have given already at 1 kilo ohm load. 1 kilo ohm load indicate that it is nothing but a load resistance. So RL value which should be 1 kilo ohm. Okay, phi DC equal to 50 volt, RL equal to 1 kilo ohm. Okay, with the ripple factor not exceeding 3%. It indicates that value. They have also given the value of the ripple factor. So notation for ripple factor, that is a R equal to 3%, indicate that 3 divided by 100. It is nothing but a 0.03. 3 divided by 100, it is nothing but a 0.03. Okay. So, okay, up to that. इथपर्यंत लक्षात आलंय का? काही सुद्धा केलं नाही आपण. गिवन थिंग जे आहेत ना ते फक्त नोट डाऊन केलं. ओके. आपल्याला यातला आता फॉर्म्युल्यानं कुठली ती काढता येते पहिल्यांदा हे पाहायचे आपण. पीडीसी दिलेला आहे, आरएल दिलेला आहे, त्यानंतर रिपलची व्हॅल्यू दिलेली आहे. ओके. सो वी नो दॅट when we have to be calculate the current through the device, that is IDC equal to VDC divided by RL, because both things we have to be known, right? So VDC means this is required VDC. Required means we have to be design the VDC of the 50. So that's why whatever the value of the current that we have to be required. That's why we have to be seen IDC equal to VDC divided by RL. So VDC value we have required, it is a 50, and RL value it is a 1 kilo. Okay. 50 divided by 1k, right? Write down 50 divided by 1k. This is nothing but a 50 divided by 1 into 10 raised to 3. Okay. So your value is, now tell me, value is 0.05. Okay. बरोबर आहे का? चेक करा, कॅल्सीवर चेक करा. 50 divided by 1k. Is it right? You direct calculate केलं ना 50 divided by 1k, direct your answer is 50 into 10 raised to minus 3. Is it correct?
Yes, sir.
Okay. 50 into 10 raised to minus 3, it indicates that 50 milliampere. Okay. Because we know that 10 raised to minus 3 indicate that milli, 10 raised to minus 6 indicate that micro, 10 raised to minus 9 indicate that nano, 10 raised to minus 12 indicate that pico. So this is a 10 raised to minus. Okay. It is the milli. So 50 milliampere. Okay. Now we have seen that selection of the filter. Right? Selection of the filter. See, this is the C type of filter. See. C type of filter. Okay. All of the things which should be required for ripple factor calculation is a R is equal to 1 divided by 4 root 3 FC into RL. Okay. We have to be write down here. See, R is equal to 1 by 4 root 3 FC into RL, because for the calculation of the, in this case, formula for ripple calculation of capacitive type of filter is R is equal to 1 divided by 4 root 3 FC into RL. So we have to be follow that formula. So we have to be calculate this formula. Accordingly, we have to know the value of the ripple factor. They have already told that whatever the ripple factor they have required, that is a 3%. Okay, 3% indicate that 0.03. So wherever R is coming, we have to be written as a 0.03. See, R we have to be written as a 0.03. Okay, 1 divided by 4 3 as it is. Frequency, see, Indian frequency of power is 50. Okay, we have to be written as a 50 for it. Capacitor value, they don't give the any capacitor value. Okay, we have written as it is as a C. Okay, RL value, we know that RL value is nothing but a 1 kilo ohm, so we have to be written as a 1k. Okay. Okay. Now calculate this thing. This thing indicate that 4 into root 3 into 50 into 1k. Calculate this. 4 into root 3 into 50 into 1k. 1k indicate that 1000. You have to write it as a 1000. So 4 into root 3 into 50 into 1000. Tell me the things.
346410.16.
Okay, whatever the answer, that is nothing but a 1 divided by this into C. Is it right? 1 divided by whatever the answer, point or not or anything, into multiply by C. Okay, for the calculation of C, C must be on the upper level. Okay, for that purposes, we have to be going this C on this side here. जे काय आन्सर आले ना ते या साईडला जाऊ द्या. Tell me the answer. 1 minute. don't have calculation. 0.03 equal to 1 divided by, tell me the answer. 1 divided by 4. Now see, 4 root 3 into 50 into 1k. What is the answer? Please tell me. Please tell me the answer.
3, 4,
Which is
346,410.
346,410
0.16.
0.16 into, see, is it right? 4 into root 3. See, 4 into root 3 into 50 into 1k. Okay, 346,410.16. Okay, into multiply by c. Is it right? Okay, c is as it is. Okay, so which is equal to 0.03. All that thing with respect to the 0.03. Okay, so now write 1 divided by answer. Write down 1 divided by answer. Tell me the value. 1 divided by answer value. Please tell me 1 divided by answer value. Means 1 divided by 346,410.16. Tell me the value. See what you have to do. 1 divided by 346,410.16. What is the answer? Tell me.
2.88 into 10 raised to minus 6.
2.2
88
Okay. Into 10 raised to
minus 6.
minus
6.
minus 6. Okay. Into c. Is it right? Into c. 1 minute. Now calculate the value of c. Is it nothing but a c? C is on this side. This 2.88 into 10 raised to minus 6. This is divided by 0.03. 0.03 divided by 2.88 into 10 raised to minus 6. Tell me the answer. Tell me the answer.
10.41 into 10 raised to 3.
10 raised to 3. Something wrong. Because here, after all calculation, 1 minute. 0.03. 0.03 equal to See, now calculate 0.03. See, 0.03 divided by 0.03 divided by 346,110.16. 0.03 divided by 346,110.16. What is the answer?
0.0866.
0.0. Please tell me 0.00.
0.0866 into 10 raised to minus 6.
10 raised to minus 6. Okay. 0.0868 into 10 raised to minus 6. Is it right? Is it right?
Yes, sir.
Okay. Which is equal to 1 by C. Why it is, I am tell you. See, your answer is 0.03, which is equal to 1 divided by 346,410.60 into C. Okay. For that purposes, we have taken 346,410.16 on another side. That is, this is for here as a divided going on another side as a one thing. It should be going on multiplied. Okay. 0.03 into multiply by 346,110.16. 1 minute. Is equal to 1 upon C. Right. See, 0.03, write down on the calculator. 0.03 into 346,110.16. What is the answer? Tell me. 0.03 into 346,110.16. What is the answer?
10.38 into 10 raised to 3.
10.30 into 10 raised to 3. Okay. Which is equal to 1 upon C. Is that correct? Because we have to be multiplied by point C. Whatever the thing coming across here, that is nothing but a 0.03, which is equal to 1 divided by 346,410.60 into C. Okay. For that purpose, 346,410.60, we are going on another side. It is a divided going on another side. It should be as like as multiplied. Okay. So 0.03 into 346,110.60, it is nothing but a 10.38 into 10 raised to 3, which is equal to 1 divided by C. Okay. So for the calculation of C, for the calculation of C is going on C 10.38 into 10 raised to 3, which is equal to 1 upon C. This C going on another side, that is a upper level. Okay. For that, 1 divided by 10.38 into 10 raised to 3. Okay. Now, how it is, I'm telling you. See, when we have to be calculate this thing indicate that R equal to 1 divided by 4 3 into FC into RL. Right. For that purposes, we have written 1 divided by 4 3 F value 50, C value as it is, RL value 1K. Okay. So when we have to be calculate 0.3 as it is. Okay. 4 root 3 into 50 into 1K. The value of it 346,410.60. Okay. This is the value of it. For that purposes, what we have to do? This thing multiply by this C. Okay. This thing going on here, it is divided by going here as a multiplied. Okay. For that, whatever the value can, it is a 10.38 into 10 raised to 3. Okay. This is equal to the 1 by C, because C is as it is. Okay. Now this C going on another side. Okay. This is on upper side. Okay. So C equal to 1 divided by 10.38 into 10 raised to 3. Now calculate 1 divided by in a bracket 1 divided by in a bracket, I don't 1 divided by in a bracket, calculate it, 1 divided by in a bracket 10.38 into 10 raised to 3 bracket complete, calculate it.
96.33 into 10 raised
Is
to
it
minus
acceptable? Is it 10 raised to minus 6 or 7?
minus 6.
Right. Whatever the value, because something 96 point something that should be changes. Please tell me the value. C equal to 96.33 into 10 raised to minus 6. Okay, so it is nothing but a 96.33 microfarad. As it is, write down as it is. Whatever is their value, it doesn't impact on, because whatever the thing which after all point that should be changes somewhat, because that is our answer. Okay, your answer is C equal to 96.33 microfarad. Okay, now we have to be see the things with respect to the capacitor value. We got now capacitor value. Second thing coming with respect to it is selection of transformer. We know that for that purposes we have doing with respect to the filter. Why filter? Because in a design step we doesn't know the value of the capacitor. Okay, because they have, when we have to be calculate the ripple factor, all of the things, value of ripple factor, frequency, RL value, we know that. We doesn't know the capacitor value because we have to be design the capacitor type of filter. So that's why during the first step we have to be calculate the value of the capacitor type of filter, that is a selection of filter. Now we have to be follow the second step, that is selection of the transformer. Write down the formula. Second step, second, selection of the transformer. Phi RMS equal to twice Vm by root 2 plus 0.7. Phi RMS equal to twice Vm divided by root 2 plus 0.7. This is the formula for the selection of the transformer. So for that purpose, we have to be use this formula, VDC formula. Okay, VDC equal to Vm minus IDC divided by 4FC. See this formula. VDC equal to Vm minus VDC divided by 4FC RL. See this formula. For the capacitor type of filter, VDC equal to Vm minus IDC divided by 4FC into RL. Okay, write down this formula. PRMS equal to twice Vm by root 2 plus 0.7. This is the thing for the calculation of the transformer, right? So for that purposes, we have required the calculation of VDC. Okay, formula for VDC calculation is Vm minus VDC divided by 4FC into RL. Okay, in this formula, we have to be known the VDC value. VDC value, why we have to know? We have to be design the 50 volt the unregulated power supply. That's why we doesn't calculate the VDC. That's why what we have to do, this Vm, see this Vm taking as here, see taking as here, and this minus VDC going on another side, right? So your thing is VDC equal to Vm minus VDC by 4FCRL. So it is nothing but a Vm as it is here. Okay, Vm equal to VDC plus VDC 4FCRL, VDC divided by 4FCRL. हे कसं आलं लक्षात येत आहे? याच्यामध्ये काय केलं सांगतो आपण. Vm as it is इथं ठेवलं, I as it is इथं असू द्या ना, ते इकडे असू द्या, as it is इथं ठेवलं, लक्षात ठेवा. आणि हे मायनस आहे ना, हे पलीकडे नेलं. ओके, ते पलीकडे जाऊन प्लस झालं, म्हणजेच VDC प्लस VDC डिवाइडेड बाय 4FC RL. ओके, हे लक्षात आलं का? कसं आलं ते प्लीज टेल मी. वेद पाठक लक्षात आलं इक्वेशन कसं आलं?
Yes, sir.
Okay, okay. Now in both equation, there should be VDC common. Write down VDC in a bracket, out of bracket. Vm equal to VDC out of bracket. For VDC, we have to be written as a 1 plus this VDC we also written as a 1 4FC RL as it is 4FC RL. Okay. Up to that, इथपर्यंत लक्षात आलंय. So now VDC value, we know that we have to be design the power supply of the 50 volts. So we know that VDC value that is a 50. Okay, 50 1 as it is plus 1 divided by 4 frequency of India, that is 50. Okay, capacitance value we have already calculated here, 96 point whatever value ourselves, 96.33. Write down here whatever the value coming, that is a 96.33 microfarad. Okay, FC value that is 96.33 microfarad. Then after all RL value it is a 1K. Okay, 1K. Now what you have to do for the calculation? Initially you don't calculate all the things. Initially you have to calculate 4.60 into 96.22. See, in a bracket, in a bracket calculate, 4.60 into 96.22 into 10 raised to minus 6. Only that calculate. In a bracket, 4.60 into 96.22 into 10 raised to minus 6. Minus 6, this is only for the microfarad purposes. Tell me that value. See, when you have to be solve the problem, do not do all the things at a time, because what happen in sometimes we doesn't use the bracket, so all of the calculation should be wrong. That's why only calculate this value initially, 4.60 into 96.22 into 10 raised to minus 6. Tell me that value.
Sir, the 4.69 15.
Into 10 raised to, see, in a bracket, how you have to be written, please tell me. In a bracket, 4.60 into 96.22 into 10 raised to minus 6, bracket complete. Is it right? You have to be done work with respect to this. अशा प्रकारेच केलंय का मी सांगितलं असं?
Sir, तिथे frequency 50 येणार ना, 60.
4 into 50, sorry, huh?
तुम्ही 60 सांगितलं.
No. Whatever thing coming across here, 4 into 50, sorry, 4.50 as I had told, but it is not. 4 into 50 into 96.22 into 10 raised to minus 6. This is the thing. Wrong. This is the wrong thing with respect to me, because this is with respect to, this is not 4.50. It is a 4 into 50 into 96.22 into 10 raised to minus 6. Okay. Whatever this calculation, please tell me.
19.26 into 10 raised to 6.
Okay, into 1000, 1K. For that 1K, it is a 1000 into 1000. Right down into 1000.
ते 1K धरूनच सांगितलंय.
हे धरून सांगितलंय का? Okay, 1 divided by answer. 1 divided by answer. Please tell me that value. 1 divided by answer. There is one of the key. It should done the operation of 1 divided by answer with respect to your calculator. If you have Casio calculator,
0.0519
Okay,
into
okay,
10
anything,
raised to
anything, plus 1, plus 1. 1 point something, is that correct?
Yes, sir.
Okay, into multiply by 50, into multiply by 50,
50.00.
value for it.
50.00 volt.
No, is it not possible? Because see, 150 into 1, it is a 50, but whatever the calculation coming with respect to this, 4 into 50, it is 100. Okay, sorry, 200 into 200 into multiply by 96.22 into 10 raised to minus 6 into multiply by 1k. It has some value, see, whatever the value, divided by, it is very less value, that is near about point something 0005. Okay, for that value divided by 1, it have value which should be near about 0.20. Okay, 1.20 into 50, that is the thing near about. Okay, that's why whatever thing, whatever the answer coming, that is not only the 50, it should be greater than 50. See, again calculate this thing. 4 into, please tell me one step. 4 into 50, it is nothing but a 200. Okay, 200 into, write down in a bracket, 200 into 200 into, in a bracket, all things are in bracket, 200 into 96.22, 200 into 96.22 into 10 raised to minus 6 into 10 raised to
96.33 घ्यायचं ना.
कोणता? 96.22. हा, जे राईट 33 आपलं जे आलंय ते 96.33. इज इट राईट? 96.33. okay, 200 into 96.33 into 10 raised to minus 6 into 1000 bracket complete, into 1000 bracket complete. Okay, 1 divided by answer. Now write down 1 divided by answer. Calculate 1 divided by whatever answer coming.
$51.90 into 10 raised to minus 3.
Okay, plus 1. Plus 1. Okay, plus 1.
1.05.
Okay, into multiply by 50 into 50.
52.59.
That is the answer. 52.59. Something changes. If something, what happen if any of the calculation, if the something changes, means 52.40, it is also answer. 52.70, it is also answer, because after all point that should be changed happen. Okay, so VM value, whatever we have to be calculation, that is VM equal to 52.59. okay, same value. Okay, now we have to be calculate the VRMS, right? For the calculation of VRMS, formula is twice VM by root 2. So VM value is 52.59. So here you have to be written as a 2 into 52.59. Okay, 2 into 52.59 divided by root 2, divided by root 2 plus 0.7. Okay, calculate that value. VM value is nothing but a 52.59. So your thing is 2 into 52.59 divided by root 2 plus 0.7. See, whatever answer coming across here, is it not possible? It should be same. It should be somewhat different. Is it not possibility? But sometimes it is a same. Okay. See.
70.75.0.
Okay. 75. How it is? See, twice Vm by root 2. Is it right? Please tell me. Twice Vm divided by root 2. Twice Vm indicate the 52.59. Okay. It is nothing but a 105, near about 105. Okay. 105. This is the value for this twice Vm. 105 divided by root 2. Now tell me 105 divided by root 2. What is the value?
74.24.
Plus 0.7. Plus 0.7.
74.94.
Okay. You have calculated this divided by root 2? No, no.
No, sir.
So what you have to do? Twice into Vm, it is nothing but a 105 divided by root 2. That is the first thing. 105 divided by root 2. First, do the calculation. 105 divided by root 2. What is the calculation?
74.24.
Okay, plus 0.7.
74.94.
Something is wrong. I'm calculating it. 1 minute. Celsius. Yes. 1 minute. See. 52.59. 52.59 into 2. Okay. 59 into 2 divided by root 2. 74.37. Okay. Plus 0.7. 75.07. Okay. Plus 0.7. So whatever the answer came across here, that is wrong. Okay. Because our answer, see, twice Vm indicate that 52.59. Okay, the whatever the value coming, that is a near about plus 0.7, that is 105. Okay, 105 value we have to be taken out as a root 2 divided. Okay, for that case your answer is 75.07. Is that correct? Please tell me.
Yes, sir.
Okay, that is the answer. Write down here as a 75.07. This is the calculated answer. Okay. For that purposes, you have to be select the transformer. See, select the transformer with 75075. Is that correct? Because they have already tell you, you have to be select the two diode. Two diode indicate that center tap type of the configuration. Okay, center tap type of the configuration. So it is nothing but a 75075. लक्षात येत आहे का हे? जरी हेच होतं कॅल्क्युलेशन मध्ये कधी कधी चुका होतात पहा. आपण स्वतः इथे कॅल्क्युलेट केलंय. फीएम ची व्हॅल्यू वगैरे कॅल्क्युलेट करून ही जी फायनल व्हॅल्यू आहे ना इथं नियर अबाउट 75. ओके, 75 व्हॅल्यू म्हणल्यानंतर आपण जो ट्रान्सफॉर्मर डिझाईन करणार आहोत तो सेंटर टॅप आहे बरोबर. म्हणून त्याच्यामध्ये ऍक्च्युली 2 व्होल्टेज असतात. कोणते सेंटर टॅप इंडिकेट मिडल इज 0. ओके, सो 75075 that is the particular value. If you have to adjust the particular 073, there should not be read. जर तुमचं इथं असतं ना 75.10 तर त्यावेळेस तिथं 76चा तुम्हाला ट्रान्सफॉर्मर यूज करावा लागला असता, म्हणजेच 76076. But whatever the value coming here 75.07, that is very less. That's why we have to be design the transformer with 75-075. If this type of the problem asked in a offline exam, this is not related to the online exam. ओके, याच्यासाठी काय करावं लागेल हे सांगतो तुम्हाला. हा प्रॉब्लेम जरी समजा इन केस ऑफ लाईफ मध्ये परत भरपूर केसेस येतात तर यू आर द इंजिनियर. ओके, इंजिनियर हा प्रॉब्लेम शुड बी कमिंग. ओके, इन दॅट केस व्हॉट यू हॅव टू डू फॉर दिस कॅल्क्युलेशन according to their any configuration, either it is a C type, L type or LC type filter, you have to select the particular case. If it is the case of C, we have to be follow the all of the row element of this. Okay, for that purposes we have to use the all of the element. Okay, initial step, see there are 3 steps for that purposes. Selection of filter, right? So selection of filter, what we have to do initially, we have to calculate the current value, because we know that I equal to V upon R. Okay, for that purposes initially we have to be calculate the value of I. After all calculating the I, we have to be find out the second thing, that is a selection of the transformer. Okay, for that purposes we know that VRM is equal to twice m by root 2 plus 0.7. This is the formula for it. Okay, for the calculation of the transformer. Okay, we have to be calculate the transformer. For that purposes, see, for that purposes we have to be know the something with respect to the this thing, that is a VDC. All that value we know, that's why we have to be calculate phi initially according to this. Okay, so we have to be calculate the phi value in this step. Okay, after all phi calculation, what we have to do, we have to be calculate the value of phi, but we need of the value of the phi RMS thing, because transformer is nothing but a AC. Okay, so here RMS is equal to, here is the formula for it, twice m by root 2 plus 0.7. Accordingly, we have to be calculate the value of the particular transformer, and they have to be tell that we need of the configuration, that is center tap. That's why we have draw the diagram, and then after all we have to be written here as a 75075 and center tap configuration. Okay, and whatever the capacity used, that is 96.33 microfarad. Okay, did you getting this? एक प्रॉब्लेम देतो तुम्हाला, मला आन्सर सांगायचं याचा. राईट डाऊन. डिझाइन अनरेग्युलेटेड पॉवर सप्लाय. Design unregulated power supply. Design unregulated power supply using capacitor. I'm again give you the example of capacitor type of filter to give DC output voltage. To give DC output voltage of 40 volt. Of 40 volt at 2 kilo ohm load. At 2 kilo ohm load. 2 kilo ohm load with ripple factor. With ripple factor not exceeding. With ripple factor not exceeding 2%. 2%. Use 4 diode rectifier circuit. Use 4 diode rectifier circuit. See, in that case, what you have to do, you have to be use the bridge type of the configuration only changes, bridge type of the configuration, and all other only value are changes. Okay, so accordingly calculate it, and tomorrow give me WhatsApp me whatever the calculation with respect to you. Okay, म्हणजे त्याच्यावर मला लक्षात येईल की तुम्हाला किती कळलंय ते. आणि ऍक्च्युली लक्षात घ्या, त्यातली जी कॅल्क्युलेशन आहेत ना, कॅल्क्युलेशन मध्ये चुकवतात बऱ्याचदा. कारण काय असते की इन अ मायक्रो मिली, if you are not using the bracket thing, then false thing will be happen. Okay, give me the attendance. Roll number 1, 2, please give me the attendance. Roll number 1, 2, 3, 4,
Present.
5, 6, 7, 8, 9,
Present, sir.
8, 9 present. Okay, 10,
Present, sir.
11, 12,
Present.
13, 14,
Present, sir.
15, 16,
Present, sir.
17, 18, 19, 20,
Present, sir.
21,
Present, sir.
22, 23,
Yes.
24, 25, 26, 27,
Yes, sir.
28,
Yes, sir.
29, 30,
Yes, sir.
31, 32, 33, 34,
Present, sir.
34, 35,
Present, sir.
36, 37, 38. Okay, absent number 1, 2, 3, 5, 7, 11, 12, 15, 17, 18, 24, 25, 26, 27, 29, 31, 32, 34, 36, 37, 38.
26.
26.
33.
Okay. 33 present आहे की.
Okay, sir.
ओके, स्टॉप करूया. डिझाईन प्रॉब्लेम ऍक्च्युली याच्यासाठी कॅल्क्युलेशन इम्पॉर्टंट पार्ट आहे. वेन सर टेल द फीडबॅक रिलेटेड थिंग, म्हणजे मला कोणाला बोलायचं नाही काय, फक्त मी डायरेक्ट सेकंडरीची मुलं असतात, डिप्लोमाची तुमची मराठी सेवा असते, दॅट्स वाय आय एम मोर मराठी इज युज्ड. आणि अनदर थिंग विथ रिस्पेक्ट टू डेरिव्हेशन, मी सांगतोय की डेरिव्हेशन सॉल्व्ह करत असताना स्टेप बाय स्टेप कशासाठी जायचं की ज्यावेळेस तुम्ही प्रॉब्लेम सॉल्व्ह करत असताना किंवा डेरिव्हेशन एखादं सॉल्व्ह करत असताना स्टेप बाय स्टेप गेल्यानंतर तेवढे स्टेप चटकन लक्षात राहते. त्यामुळे स्टेप बाय स्टेप तुम्ही डेरिव्हेशन फॉलो करत जावा. ओके ओके, स्टॉप करूया. दिस इज द एंड ऑफ द दिस चॅप्टर. नाऊ देर शुड बी टेस्ट EDC. ओके, 5व्या चॅप्टरची टेस्ट उद्या घेऊया आपण. ओके, आता EDC ची टेस्ट असेल, रिआयसी. ओके ओके, स्टॉप करूया आपण.